All right, everyone. So let's get started with our next session. That will be the Kafka KSQLDB showcase. Let me share my whole screen. All right, so Kafka KSQLDB showcase. Let's get started. So what can we expect from this session? We want to show you how to get data from Kafka into data virtuality. So we will be illustrating the topics of what is Kafka. We were going to make a definition here. What's KSQLDB? The use cases that we see for data virtualization, and probably the use cases that you also see for data virtualization together with streaming and Kafka. Then we will take a look on how to connect to a KSQLDB database, and then looking at the syntax specialties, and then doing some queries from DV along the way. So what is Kafka is the first question. So there's three abilities to Kafka. You know, it's of course, everyone knows this is somehow streaming data, but it's the ability to publish, write, and read streams of events. And that means continuous import and export from of data from other systems and vice versa. So you can use it to transfer data. We are using a different approach at data virtuality. For us, it's most of the time it's JDBC, REST API, and now OData after Carlos's session. And another ability is to store the streams, right? So the stream data is being kept on the cluster, but for as long as you want, but also not much longer, right? So there's also, we will talk about retention of data in Kafka streams as well. And then the ability to process streams of events. So as they occur, so when an event is happening, but also retrospectively, so you can also replay a series of events. That's also very important. Regarding the terminology today, we're going to be talking about events that are stored in topics, and we will be defining this also in our interface here. Topics are partitioned. And now let's, after we took a look at the abilities and the terminology, now let's take a look at the challenges for data virtualization. As I was already mentioning, we do it a little bit differently, the way we transport data, and usually the events, they are active, right? So someone is publishing somewhere, it's writing to a destination, so we should actually react, but we are more or less a passive system, because from your knowledge also of data virtualization and data virtuality in particular, you would issue a query, you would run a command or a procedure, and then DV would gather all the data and give you a reply, or give a reply to another system, or move the data that is coming from there. But for an event, and if you look at Kafka with probably many events, it's not really an approach, or it's a challenge we have to face. So another one would be, if we are querying some Kafka entity, if we're querying a Kafka stream, then new events would be coming in, and we will see this in the KSQLDB interface. It basically shows you streaming results, and new events as they're happening are displayed on the stream. But for us, we do have a streaming results set, but usually when we display them, or when we need to write them, there needs to be a certain transaction around it so that it's finished, and we can say we now have all the data, or we now put all the data into the destination where we wanted to write it to. And another challenge for data virtualization, if you're now saying we can just consume data from Kafka streams because there is a retention for them, there's also a retention period where the data disappears. So we also need to be dealing with this as a challenge in data virtualization. All right, so let's talk about the use cases. So the use cases are first the use cases for Kafka itself. So I took this from the Kafka website, and now it's some exercise for you guys, and I hope I will get some replies. What would be your use cases? So what would you see as a use case for data virtuality together with Kafka? Please write them into the chat right now. If there's no chat available, Nadine, I don't know if we have enabled the chat, but there's definitely Q&A available, right? I'm not sure if we can chat with each other, but definitely Q&A is available. So please write your use cases into the chat right now if you have any. So the ones that coming from Kafka, and I will talk about them a little bit later, will be messaging, website activity tracking. That's really the most classical Kafka use case. Metrics and operational monitoring. So they just call it metrics, but in the end, it's operational monitoring, log aggregation, stream processing, event sourcing, and commit log. So if anyone has any use cases, please go ahead. Let me see if I can bring up the Q&A here. Yeah, if you have any, you can still continue to put them into the questions and answers or into our chat. But let's now take a look at the commented version of this, right? So I just want to make some comments on that. Let me just move these things away here. So messaging. So sending messages from a DV automation is possible. So that it does not only mean that there's reading, that it's necessarily reading. So data virtuality is really probably, especially the platform, really we call the platform, it's a platform for data where you can move the data and where you can not only react to data and move it to a BI tool, but you can also react on data and move it around different systems. So that means that also DV could be sending messages. For me, it's a great use case. A website activity tracking, that would be the most classical Kafka use case. We would join this to the data we have, because for us, most of the time it's integration is the question. So we would integrate into this tracking and correlate this, for example, with shopping or information on the users, and then send out reports based on that. So Sebastian here put one use case in, so that would be continuous materialization of changes in DV. So that would be kind of some CDC, and I can also will comment on that after the other ones. So metrics possible in a pull configuration, so we can pull like things like the events that happened in a set of machines, and we could also emit metrics from DV. So we got our own measurements, the query performance log, for example, where we can send performance data to somewhere else, to a central entity that would be looking at the general health status of all of them. Log aggregation, so abstraction for log files. Not sure if I see much of that. Stream processing, for me, it's a very large use case, because we can integrate the results of processed and aggregated streams, right? So the data is happening, and we can, for example, look back at the window in time and retrieve this data and then join it to our data. So that is a great integration use case where we probably also can build some dashboards and feed them. So event sourcing is where the state changes are logged as a real-time ordered sequence of records. So probably a little bit in the direction that Sebastian is going. And But again, it's probably about log data, so it's not about moving data really. And finally, a commit log, so external commit log for a distributed system. Probably also in the tough to implement this in the style of a data integration with DV. So regarding the use case that Sebastian wrote here, continuous materialization of changes in DV, that would go into the direction of a CDC connector. So change data capture, being able to materialize data, yes, and basically into our analytical storage, for example. And we do have something there in progress on our side. So we are talking about the Debezium implementation. And this is also if you want to materialize data from a Kafka stream, just basically replicate the results into that or replicate the events into a database, then you would also be using Debezium. So that is our approach. But we will just put this in, and we will also take a look at this use case on our side if we can implement this with a Kafka connector, with the KSQLDB connector. So thank you for this good use case, and we're going to take a look at this later on. Okay, so has been answered. Let's move on. So what is KSQLDB? So this is part of the Confluent platform. So this is a Kafka distribution with some extra things. I also installed this here for our use case. I installed this Kafka here on my system with all the different things. We see here a complete distribution here with the command line interface with the control center, the data generator, the KSQLDB server itself, Kafka Connect to connect to external systems, a REST API, the schema registry that stores all the schemas, the broker and the zookeeper. They are taking charge of all the machines and their orchestration here. All right, so we got the Kafka distribution up and running. KSQLDB provides an SQL bridge to Kafka, if you will. So that sounds good for me, right? So because we, especially not only data virtualization, but also data virtuality in specific is an SQL on top of everything. So we want to have this bridge available, and we just want to fire queries against KSQLDB, which will then in turn talk to streams and tables and in the KSQLDB. So the KSQLDB is a stream processing database, and these are the capabilities. They're listed in details here on their documentation. And we're going to be doing this throughout this session here. So you can derive a new stream from an existing stream. So you could, for example, say, I filter something. Right, so I create a new stream from a Kafka stream where I say I only listen to events that happen for a couple of users. I mean a where statement basically on a Kafka stream. We can derive a new table from an existing stream. And we will talk about the difference between stream and table in a second as well. And we can derive a new table from an existing table, right? So now we get all the permutations basically, and we can derive a new stream from multiple streams, but we can probably not derive a stream from a table. That's something that's not possible. And in the end, it's basically input streams are coming in by streams producer, and then KSQLDB is doing this processing on the streams. That's exactly the processing, the four different processes we saw here for stream processing. And then there's output streams, and of course, tables can be mentioned here. All right. Okay, let's continue. So streams and tables, I promised to illustrate this a little bit so we see the difference, right? So stream is really, it's immutable, append-only collection, right? So it's really a stream, events are happening and you cannot change an event in the past, right? Events are just fired into the stream and they have their timestamp, but they will not change. You will not see an event that replaces another event, right? So you could, for example, have events that show transactions. So of course, someone gets money and then they spend the money again. That would be happening, but this would then be an implicit thing about the balance. So in a stream, data never changes, and you can append rows to the stream at the end, always only at the end of the stream, right? So if there is an event, there cannot be an event inserted that is before that event. And of course, there's no update and delete on existing rows. So now the difference, a table, and we're talking about the table in KSQLDB. And that is a mutable connection that where which models the changes over time, and we need a row key. So we will be seeing this when we create our table. We will need to provide a primary key to display the recent data for each key, right? And data is deleted periodically, so it's a kind of a table is showing the snapshot of the latest data rather than having all the things of a stream in it. And also each row has a timestamp. So you can also take a look at a window of time. We will also be doing this in our showcase at a window of time. For example, let's say we're going to be using 30 seconds. So you look at events in the last 30 seconds, put them into a table, and then you can take a look at these timestamp. All right, so let's continue. So the query types. So how can we query data in KSQLDB? We can create persistent queries. These are queries that you create on the server side, and once they are there, they remain on the KSQLDB. There are also queries that disappear after it, but these ones definitely create a stream or populate a table, and they are going to be remaining. It's not that they are that these are exclusive types, right? So a push query can be a persistent query, for example. So push query is issued by a client and subscribes to a result as it is changing in real time, right? Okay, important here, changes in real time. So push query would really show us, continue to show us the data while the stream is running and producing results, and we are probably aggregating or looking at a time window, but there is no definite answer to this. So that is kind of something that we probably is a challenge in data virtualization. When we're joining it to other data, we want it, we want a pull query. So pull query is a form of query issued by a client that retrieves a result as of now. Exactly my point. Like a query against a traditional database management system. So in my opinion, that is a very, very good way to integrate to data virtuality. So let's take a look at this. So let's look at the options to connect to data to KSQLDB from Kafka. Right, so the first one is via REST API actually. So it has always been there, and I can also do a REST API query. I will be doing this as the first one. And then there is a generic JDBC driver that we've been using. So you can configure this using this driver, but there are some challenges regarding how you can really query KSQL. So you always need some specific changes. You need to hit some primary keys, as I was illustrating before here, especially when you're looking at a windowed operation. You need to basically have the real keys that you hit. So you cannot just put arbitrary SQL in it. This is why this is kind of challenging with data virtuality. And finally, there's a DV driver now in QA on our side, and that's which is actually implementing this Java client of KSQLDB. It is a Java client for us, so it sits inside the server. You just configure it as we configure it internally as a JDBC driver, but in the end, this one will also be putting REST API queries against the KSQLDB. All right, so let's take a look. Let's take a look at the first option. So REST API, very powerful way to interact with KSQLDB because there's many endpoints. You probably will not hit with SQL or will not hit with a JDBC interface. There's a whole documentation for the REST API there, and again, we have the push queries. You remember this problem, the challenge of a streaming result set, right? So here it says, so I'm doing a quote here, execute a push query by sending an HTTP request to the REST API, and the API sends back a chunk response of indefinite length, right? Again, the challenge where we press play, it probably even works, but you will not ever get a finite reply, and that is a challenge. So what we want is pull queries. Just to illustrate how it works, let's just look into our DB Studio here, into our KSQL demo, and the REST call looks something like this. So let me just copy this one, and then we do our let's copy these two probably, and let's use our JSON builder here. Go to a web service. Let me just put this somewhere here, a little bit more room, and use our endpoint, which is just the endpoint that we want to connect to. So this is my localhost here running in Docker. Let's look it up. So AT80 is the KSQLDB server. So we're going to be connecting to this one using REST API, and I think this is also one of the few ways to connect to this. And then now some query, we're going to do a post request, and we will put this stuff in here, and now we can just apply this, and we are retrieving the first data. Is just the show streams statement, but you see here you got KSQL, so you can pass arbitrary SQL to it. KSQL. So in the syntax of KSQL, the beautiful thing here, of course, is that it terminates, right? Because we got a finite number of streams. There are no events streamed in there while our thing is running. And in the we already see here all the streams. And in the row configuration, one challenge here, and you probably know this from the JSON wizard, and I want to also tell you a little bit about my challenges here, and probably something you saw already with this unexpected multi-valued result, right? It's now very difficult to access things that are named in exactly the same way, and I've stopped many times using that and wrote the query directly. But if you go one element deeper here on the streams itself, we can already see the data, right? So really with the wizard, you got to be careful where you are clicking, and probably can even put this is windowed still into it. I never like this ID column, so I'm just removing it. It's probably way too long for the precision, but I mean, we're talking about our KSQL integration, so we don't want to dwell too long on our JSON wizard here. But finally, we have our query, and we can just run it. And this is now a live query against KSQLDB. It's not getting data as in terms of data from a Kafka stream yet, but you can probably use this, expand this showcase with all the KSQL you can think of. And there's also a KSQL interface. So if we look at our control center here, I have my whole cluster in here, my control center cluster, and here I can also issue queries to my KSQLDB directly. And here, for example, we can also do a thing like show streams, and then it would just show me all the different streams here. Or you can even see it's showing me the same format here as I was pulling in with my wizard. So that is actually, show streams is actually emitting JSON. All right. Okay, let's continue. Go back to our showcase here. And so I just pointed the different, the important things here. And okay, let's continue. So the next possibility here is to connect a KSQLDB connection with a driver. We can also provide the driver to you. It's currently in quality assurance, and it implements the Java client we already talked about. And so just about the things that the client can do, it's kind of a Java bridge to REST API for KSQLDB. So we see pull and push queries, inserting rows of data into existing KSQLDB streams. So this actually will enable you to write data into streams. Creation and management of new streams, tables, and persistent queries. So we know all of this terminology. And also admin operations such as listing streams, tables, and topics. All right, so the create connection, create data source, these are the two commands, not much to do. The interesting thing is, of course, you don't have this KSQL translator yet. So let's take a look what this sounds and looks like in data virtuality. So I just, for the sake of the demo, I just did a reconnect to KSQLDB, so it will remove the connection and then just create it again. And there's not much happening. As we don't have a wizard for this, I cannot really add it and show it for you. I could just remove it and create it again. All right, so we got the connection here. And this one is now showing all the different things, tables. We see here, we see streams, we see derived streams, and some test data. So the metadata of the object is really coming in, and we can inspect this. Data sizes are fairly large. And let's continue here. All right, creating and querying objects in KSQLDB. So the first one, we're going to be following the Confluent platform quick start. That is just basically not only for KSQLDB, but does basically show the whole distribution of Kafka and all the different objects I showed you in the Docker here. And so it's first goes about installing, but then we go into the cluster as we've seen it already. And then the first one is to create the topics, right? We remember topics is where streams put their events to. And what we're doing here is we are creating a page views topics, and we are creating a user topic. And let's take a look at this control center topics. And there we see many, many more that I already created, but our page views topic, we can see it here. And this one is really producing records as we speak. So yeah, pulling a little bit of stress on my system. And we can see this one creating messages. and the other one would be the users topic. And there also we see on the left-hand side the production of events and also the consumption. So we remember there's always a producer and a consumer at the end of the streams, but of course it can be also 0 consumers, but producer needs to be there. And we also see how much data this is already containing, how much data is in there for the users. And I think for the page views, it's much more, because we're going to be looking here in our how we created the mock data, and that was actually with different things. So the first one is data gen for page views, and it will be put into the topic page views. And the other one is for the users, and we see this interval. I think that's per second. So we see this interval between users. Sorry, that's milliseconds. So there's one user, basically new user being created once per second. And here we see 100 milliseconds between events. So there is 10 page views created per second. And that already shows us the difference between the storage, how much data is needed to preserve these the topics in the end. All right, so let's continue here with our quick start, and then finally we're now creating these data generators. And finally, we can take a look at this user data, for example. So I'm navigating here to my topic of users. And there I can take a look at the messages. So if we can see here once a second, probably there is a new user registered, and we see the data generator, by the way, coming from the connect portion here. And they are producing these new messages, and I can take a look into them and basically review the key, review everything about a single message here. And as we can see, as the producer is running all the time, it's actually there is no pause, right? So we never have all the data because it's continuously being pushed into the user's topic. All right, let's continue now with our creating and querying. So here we created this stream page views. We already did this on the I already did this on the system, but we can see here the interesting parameters. So the first one is really we're using the native function, right? Because this is something that is definitely not part of data virtuality SQL. So we need a native function to give something, hand it over to the KSQLDB Java client, which will then in turn create the REST API call internally and get the data. In this place, we are not looking at data, we are not retrieving data, but we are issuing a statement. So that already tells us for the second parameter that this can be a statement, query, or stream. All right. So a statement and query are most interesting for us. Stream is kind of difficult. And if we run this statement, it will probably tell me that this one already exists, or it would there's no data coming back, so everything is fine. There was no error with it, and we basically replaced the stream page views stream with the writing to the page views Kafka, and in the format of Avro, which is, I think, JSON as a description and then binary contents. All right. Next one, we can now do a direct select, right? So we have our page view stream created, and now we can go ahead and jump into here, and let's take a look at page view stream. So we see it's running and running and running because this stream is constantly continuing to get results. So let's see if we can limit this. And now, of course, it will be interesting what DV does with this limitation. So the interesting part here is because I limited it, we made it a pull query, and then we can also get a result, right? But you probably now see the challenges of continuous data integration with data virtuality versus streams that we don't get a result. Sometimes we get it if it's possible to stream it, so it's kind of difficult. And here we see the limitation. Interestingly, if you remember this, we are selecting this from the statement, and then we're applying the limit later on. For me, that is a little bit surprising because I would imagine the limit being pushed down as we send the whole query to it, but this is the way we are doing it. And if you really want to push it down, if you want the limitation to be inside of the query, you can still use the native command here. So instead of selecting from it and definitely you need to use this limit. We can also use a native connection. That means we push the whole query to the system, to the connection. And if we use the second one here, that would be another way of expressing that. And that's basically, here we see this whole thing a little bit. We need to still unpack it. And that would be the array table function, where you can get out of this array that is being returned from the query, you can put the column names and the column data types on it. So that would be the second SQL here. All right. So are there any questions right now? No questions. Okay, let's continue. So now let's look at this table, at creating a table. So I already said that the tables in KSQLDB need a primary key because they want to be able to answer select statements about time frames, for example. And here we are just creating a table that doesn't change anything about it and just gets a table from the Kafka topic users, puts it in Avro, and again, we're using a native command to store this in a statement, and the result will be the same for each query. Now it's interesting if we look at this users table. So first we're going to look at it in our control center. KSQLDB, let's go for tables, users table, query the table. So now again, of course, we see here the stream still producing results because they're coming in and are being inserted on top of the table. If we do this from our data virtuality client, though, we will always have the top information here. So let's take a look at the users table here, just query it. And again, we don't instantly get a result. It really depends on how much where the offset is. So there's actually an offset of messages that haven't been consumed. We can see this in the consumer section here. Can actually see for the queries that I created, how many messages behind the system is. And let's now limit this again. Let's run it again, the query. So now we see here, with this limit, we remember this 266 on top here. And if I run this query again, of course, now it's again forwarding this. And here we see it's the same number, right? So we always, this is what I wanted to illustrate here, as we are now querying a table, we are always getting the same result from the beginning. And if I, let me just run the statement probably without the limit. Let's just see if we can get it. Yeah, so we see here this now stays in fetching mode. And this is this beautiful result set. I didn't put any limit on it, and I can scroll and it will read the next batches. As I scroll down, we'll need to read the next messages, and I can scroll infinitely because we saw the numbers here. So there's many rows to scroll now. So that is one of the behavior where data virtuality actually can look at a thing or look at a streaming result from this table. But of course, how we wouldn't be able to replicate that, right? Probably by the register time, but a streaming result set is very difficult to catch with our select into or with our job that integrate data. All right, so let's go back to our showcase here. Now, pull queries. So let's take a look at the challenge for the pull queries, right? So I just now want to get data in KSQLDB, and I want to get the data. Let me just paste it here. I want to get data from the users table. So let's just probably do it without the limitation here. We remember. Go ahead. Okay, so we see here from a users table, I cannot really directly query. So I have to use this emit changes. This is something that you hit very often when dealing with KSQLDB, and that basically means the ability of the system to show the changes while the SQL is running, right? It will not stop running until I really stop it. And now, of course, okay, I don't want to have, I want a finite result. And now we see the challenge here. If we run this query now, go ahead. There we go. Right now we have a problem, and I also note this down. So here, add emit changes if you intend to issue a push query, right? So we get this. This is why I was dwelling on push and pull queries in the beginning to have an understanding. And here it says that for a pull query, I need a where statement that includes a key equality expression, like for example, key column equals something. So let's go back to our thing here. Okay, so I followed the specifics of what the system said to me. I think this one qualifies, right? Selects everything from users table where ID equals user3. Let's run it. Let's run it with a semicolon in the end. And again, we see the same problem. What I can do here is now create a queryable table. And this is in the end what I did. And this then enabled me, here we go, also to have a table where I can select from directly. But we can see a little bit the difference here on how our KSQLDB connector behaves from DV. It's really a client, while this one issues the statements directly, right? So the select star from users table, it actually worked in DV, while without image changes or without any parameters, it does not work at all, right? It won't let me do that without image changes, but in data virtuality, it worked because we internally add this image changes. But then it's a streaming result set, and you basically have to have a challenge to, right, here we go. And I can now issue this statement on my users table with a register time. So it actually allows me to do that in DV. So it does not really make not all the limitations that we see here in the KSQLDB when querying it directly. Not all of these limitations are present in the data virtuality connector as well. Let's move to our next one. So now we are talking about a joint stream, right? So we are now joining the stream. Sorry, we're joining the tables. Users table, and we're joining it with a stream. And this is now we are getting at the interesting part where KSQLDB is actually doing its own processing. So we now really use this as the stream processing database where input streams are coming together, the streams are joined, and then some stream is outputted. All right, so let's, I created this stream already, and we can see this interestingly here in the KSQLDB flow. We actually see now the page view stream and the users table in a create stream operation are now put together as user page view, and we can see now this is always a combination of the user details that we already have and the page view. So they are joined, and then we see all the information coming here. So user and page ID going together. And now we can also query this from data virtuality. But what I want to illustrate here a little bit more is that the important part is that some of the operation really need to happen on the KSQLDB side, right? So it's the same thing as if I want to do a push down, but I think it's would be a challenge if you say I'm just now joining from DV these two things, the users tables and the page view stream. If I join them in DV, it's not explicitly creating a new stream. You need to do this. So you need to kind of prepare what kind of analytics you want to do. You can also do aggregation over time or compacted topics and then query them. All right, so let's query this in data virtuality. So that's the user page view. And we see here again, I was putting a limit on it because the result basically never ends. And with a limit, I get this information. And if we query again, we see that this is different data each time, right? So we're looking at a stream again, and it's not being written from the beginning as we saw it with a table, but it's really a snapshot in time about 10 different objects here in the stream. All right. Now the other one is right here, the filtered stream, right? So sorry about this. Let's duplicate. Okay. So the filtered stream is now we are still remaining on our user page view stream that we just created, and now we are filtering this stream with a region where region like 8 or region like 9. And this is a derived stream. And again, KSQLDB is doing the processing here. Page views, region like. Here we go. And of course, we would need our limit again for this for the result to appear. And what's going on? And let's take a look at how this looks like on the KSQLDB side. If we now move on further to the right in our stream that we created together here, we see here now the page views region like 89. Now we have a on this first we have the two streams, right? We're consuming them, we're joining them, and now we're applying a filter on top of this. And here now we would only see region 8 and region 9 appear, and then finally we are creating a table from it. And here's still interesting now, the window table, right? So the about, as I was mentioning in the beginning, that is about the window of time. So it's basically analyzing the last 30 seconds of a time frame and then counting the number of users. So we will have the first user, then num users would be 1. We will have the second users, then num users will be 2, and so forth. And this is done for the last 30 seconds, right? And the grouping, and finally, this now is again a persistent queries because I created the table. And let's inspect this table as well. And that would be our page views per region. And this is now, can I expand this? Really. The interesting, I really need to do this from DV now because it's invisible for me. So let's get back here and let's do page views for, and here now we see actually the number of users being counted, right? So user 2 male region 8 2, and then if we see that again, it will be region 8. Where is the next 3? Probably here, user, I don't know. So it's basically counting. We see it right here, user 3 male, and now we see the count and all of this thing for these 30 seconds. What happened in the 30 seconds, right? So we did some count on a time window in a stream, because you have to think differently when you are accessing the data in the stream. And want to put this in data virtuality. That's a challenge. Now we put so much data in here that we, I think, have enough of reading the data. There's also probably interesting how the data is persisted, and we can also, there is a overview of the persisted queries that we can see here. And finally, now, if we are looking at our presentation again, there is a the ability to create the tables. As I was mentioning, this our connector enables you to create this. So that would be really just a native call again to our KSQLDB connection, saying create table with where it needs to be put in terms of topic, what the format will be like, how many partitions, and then also the information here. And then after that, we insert into this table, right? And this gives us the ability to write data from DV and back into Kafka streams using KSQLDB. And Another one, just another statement here with a little bit more details would be the insert into this rider locations. So that would be a query where I can basically determine if a specific rider is in a specific place. And this is also possible to retrieve this data then if I have a table that contains the data where these with the where statement. That is another quick start that you can also pick up on the Confluent. That would enable you to do some analytics and also have final locations of these riders, because again, we now have here a stream of data where positions are constantly being updated. And if you want to have the eventual one, or you want to know all the riders that are in a specific place, then you can use this one. All right, so that has been much. Are there any questions right now? Let me just check if there's something in the questions. Okay, no questions right now. Regarding the our time, I think 15 minutes was a very, very long break last time. Would you like this to be thank you. Thank you. So someone just wrote a really good demo, Matthias. Thank you. Yeah, so it was really getting to know Kafka from the start, like probably some of you also did, getting to know KSQLDB from the start, and then implementing that with our connector. Yeah, I'm very happy that you liked this. You definitely stay tuned for Carlos's next thing with the relational procedural command. And also, I think, Nadine, we will have a poll after this, right? We will send the guys a poll, and we need your feedback desperately. And I'm so happy that there are now many participants in here today because we want to know what kind of topics you would like to hear in the next masterclass.
If there is no poll automated, then we will send one.
We will send a poll. And now everyone hands up if you want to have a shorter break. Okay, 1 hand up, 3, 4. Everyone, go ahead. Throw your hands in the air. It's not democratic yet. Okay, okay, it's more and more coming in. Yeah, since the hands are being put down again, I think now we have the number. Let's just do 5 minutes if it's okay for everyone, and then Carlos will start. Okay, so let's take a short break, everyone.